Hey everybody, hope you guys are doing well. So I am recording this on Thursday night, and the weather forecast is calling for like 3 to 6 inches of snow tonight. So by the time you're watching this video, there very well could be a couple of inches of snow on the ground, which seems absurd to me because it is halfway through April now, and we are getting that much snow is kind of not fair, you know. Like I feel like we should be having sunshine and warm weather by now, and it's just, just gross. Sickens me out, man. We're supposed to be having spring. I mean, we're past spring break. It's supposed to be warm and sunny. You know, we should, even though we're quarantined, we should at least be able to hang out outside a little bit. But because we're getting snow, it's not looking like we're going to be able to. At least today we're not. Hopefully it goes away soon. We start seeing some warmer weather though, so we can enjoy that outside weather though. All right, so we are going to continue on with this module. We're talking about probability in this module. By the way, Wednesday had a couple people show up to the Q&A session. It was great to see those of you that showed up. We're going to have another one of those for Math 8 on next Wednesday at 1 p.m. to 2 p.m. So again, if you have any questions over any of these assignments that we're doing, any of these lessons, feel free to come on by, get help. Even if you just want to hang out and say hi. A couple of people just came by and said hello. So that's perfectly okay. I miss you guys, and I'd love to see you guys again. So come on by next Wednesday. All right, so our objective for today is to describe and understand compound events. Okay, so independent compound probability. A compound event, again, I would recommend taking notes on these. A compound event is an event that is made up of two or more simple events. Okay, so we talked on Wednesday about simple events. That's when we're doing just one thing. Maybe one flip of a coin. Or maybe you've got some marbles in a bag and you're picking one marble out to see what the result is. That's a simple event when just one thing happens. A compound event is an event that's made up of two or more simple events. So you're doing two things. So maybe you're picking out two marbles from the bag. Or maybe you have a deck of cards and you're going to draw two cards from the deck to see what you get. Okay? Or maybe you're flipping that coin twice. Or maybe you're rolling the dice twice. Okay? Something like that. Flipping a coin and rolling a number cube are independent events. Events are independent if the outcome of one event does not affect the probability of another event. Let me explain that a little bit. So like if you flip a coin and then roll a dice, a number cube is the same thing as a dice, by the way. So if I flip a coin, does flipping a coin affect the outcome that I could get from rolling a dice? No. Right? That coin is not going to change the fact that I could still get a 1, 2, 3, 4, 5, or 6 on the dice. Right? Now, think about like this. Let's say I have a deck of cards, and I draw out the ace of spades. Okay? And then let's say I want to draw another card. Okay? I take my ace of spades and put it off to the side. Does that affect what I could get in the deck of cards the second draw? If I don't put the ace of spades back in, if I just put it off to the side? Yeah, it changes now, right? I can no longer draw the ace of spades in this deck. So these are not independent, these are dependent. Because what I draw now next in my deck depends on what I drew in the first draw. Okay, so those compound events would be dependent. Okay, independent events are when they don't affect each other. All right, so let's look at number A here, or letter A. Letter A, a box contains 5 red marbles and 5 blue marbles. Okay, what are the possible outcomes of drawing one marble from the box? So I'm just drawing one marble. Okay, what could I get? Well, this is not a super complicated question. I could get a red marble, or I could get blue, right? I'm just drawing one marble here, right? Now, what do you guys think? What's the probability of drawing a red marble? Okay, well, the probability of drawing a red marble, so there's 5 red marbles in it, right? And there's a total of 10 marbles. So that's a 5 out of 10 chance of drawing a red marble, which is a 1/2 probability. Okay, let's look at letter B. Part B. Suppose you draw a first marble. Okay, you pick one marble out, then replace it, so I'm putting it back in after I pick it out, and then you draw a second marble. What are the possible outcomes for the second draw? Okay, so if I pick a marble out and put it back in, and then I draw a second time, what could I get the second time? Well, my outcomes really haven't changed if I put the marble back in. I can still get red or blue, right? I still have the chance of getting a red or a blue marble. In fact, it's still equal because I put it back in. I still have the 50-50 chance. Part C. Complete the list of all possible outcomes of drawing a first marble. Actually, let's go back to B. So we talked about on A, the probability of drawing a red marble is 1/2, right? What do you think the probability of drawing a red marble on the second pick is? Okay, so if I draw a marble, put it back in, is the probability still 1/2 now of picking a red marble? Well, if I put the marble back in, yes, there's still 10 total marbles in the bag, and there's still 5 marbles in it, or 5 red marbles, because even if I drew a red marble in the first one, I'm putting it back in the bag, so there's still 5 possible reds. So my probability is still 1/2 on the second pick. Okay. And then part C, complete the list of all possible outcomes of drawing a first marble, replacing it, then drawing a second marble. So I'm picking a marble out, putting it back, picking a second one. What are the possible outcomes I could get? Well, my first one here, I could get a red and then a red, right? I could get a red and then a blue. What else could I get? I could get a blue with my first pick, right? I could get a blue and then a blue. And then I could also get a blue and then a red. Okay, so I could get a red and red both times. I could get a red first, then a blue. I could get blue both times, or I could get blue first and then red. Okay, so there's 4 possible outcomes here for this compound event. Okay, so what do you guys think then that the probability is of drawing a red marble and then another red marble? So what's the probability then of me getting 2 reds in a row in this situation? Well, we just said there's 4 possible outcomes. How many of those outcomes are double red? Well, there's only one outcome that gives me 2 reds, right? So there's a 1/4 chance of getting 2 reds in a row. Okay? All right, now let's look at, so that was independent compound probability. Let's look at dependent compound probability now. A compound event can include dependent events, which are events for which the outcome of one event affects the probability of the second event. So we just talked about how when you're doing your first event, it changes the probability of the second event. That's what a dependent event is. So part A here says, a box contains 5 green marbles and 5 yellow marbles. So green marbles we'll call G, yellow marbles we'll represent with a Y. What are the possible outcomes of drawing 1 marble from the box? Well, you could get a green or a yellow, right? Green or yellow, those are your possible outcomes from drawing 1 marble from a box. Part B. Suppose you draw a first marble. You do not replace it, so you take a marble out and just put it off to the side. Then you draw a second marble. What are the possible outcomes of the second draw? Well, if you're just drawing 1, there's still both green and yellow marbles in there, right? Now, one of them is going to have 1 less, but there's still green or yellow in there. So your possible outcomes, you could get green or yellow, right? Now, let's talk about this for a second. So part A, what's the probability of drawing a green marble on your first draw? Well, so there's 5 greens, right? So there's 5 favorable marbles, and then there's a total of 10 marbles, right? So there's 5 out of 10, which is a 1/2 probability of getting green. What's the probability of getting green again on your second draw? Okay, so hang on. Actually, we'll get to that. Let me rewind. We'll get to that here in part C. Okay, so first it says complete the list of all possible outcomes of drawing a first marble, not replacing it, and then drawing a second marble. So you could get green, right? You could get green yellow, right? you could get yellow, green, so yellow first, then green, or you could get 2 yellows. So there's 4 possible outcomes for this compound event. Okay. Now, let's go back to B now. Let's say I drew a green on my first marble. Okay, so I take that green, I put it out. What do you think the probability is now that I pick a green on my second draw? Okay, a green on my second draw. Okay, so let's go back. So like our probability, how many possible outcomes are there now? Are there still 10 possible outcomes? No, there's no longer 10 marbles in the bag, right? Since I drew one out and put it off to the side, now there's only 9 possible marbles in it. And if I drew a green on my first draw, how many possible greens are left? There's only 4 now, right? So the probability that I get a green on my second draw is 4 out of 9. Okay. All right. Part number 3 here says a bag contains 8 white marbles and 5 pink marbles. So part A, you draw a pink marble at random, replace it, and then draw another pink marble at random. What's the probability of each event? So the key thing here that we want to look at is this part that says replace it. So we draw it out and replace it back into the bag. Is that a dependent or an independent? Are these dependent or independent events? Well, since we are replacing it back in, the first draw does not affect the second draw. There's still the same number of marbles in the bag as in the first draw as the second draw, since we're putting it back in. So these are independent events. Okay, so the probability that the first marble is pink. Well, there's 8 white marbles and 5 pink marbles, so there's 5 favorable pinks. How many total marbles are there in the bag? Well, 8 plus 5 is 13. So the probability that the first marble is pink is 5/13. Next, the probability that the second marble is pink. Okay, so we took the first marble out, it's pink, we put it back in. What's the probability that we get a pink again? Okay, well, the probabilities are not going to change here. Since we have independent events, we still have all the same marbles back in the bag. The probability does not change. It's still 5 pink marbles out of a total of 13 marbles. Okay? All right, part B. Suppose you draw a pink marble at random, then you do not replace it, and then draw another pink marble at random. What's the probability of each event? So first, what's the probability that the first marble is pink? Well, the probability that the first marble is pink is still 5/13. Okay, so I pick a pink marble out, put it off to the side, and now I want to pick another marble. Okay, now let's figure out the probability there. Are there still 5 pinks in there? No, because I just drew one out. So now there's only 4 pinks left in the bag out of how many total marbles? Well, you might think 13, right? But no, there's 1 fewer marble in the bag now, so now there are only 12 marbles. Okay, 4/12 now. We want to reduce this then. 4/12 can reduce to 1/3. So we have a 1/3 probability that the second marble that we draw is pink. Okay. All right. A bag contains 6 red coins and 12 green coins. A coin is selected at random. Find the probability of each event. Okay. So part A. The probability of selecting a green coin on the first draw. So here we've got 6 red coins and 6 green coins. We want to know the probability of getting green. So we'll write it like this. The probability of green. Okay, well, there's 12 green coins out of a total of 6 plus 12 total coins, which is 18. Okay, this now can be reduced. 12 and 18 can both be divided by 6, so 12 divided by 6 is 2. 18 divided by 6 is 3, which gives us a probability of 2/3. Okay, part B, selecting a red coin after a green coin is selected and replaced. So we are replacing the first coin. We're drawing a coin, putting it back in. Okay, so what's the probability of selecting a red coin after a green coin is selected and not replaced? Well, these are independent events since it's being replaced. So basically selecting a red coin isn't affected by us selecting a green coin first. So all the coins are back in the bag for the second pick, right? So we want to know the probability of getting red on the second pick. Well, there's 6 red coins out of a total of 18 coins. 6 over 18 reduces to 1/3. Okay? And now C. We want to know the probability of selecting a red coin after a green coin is selected and not replaced. So I take a green coin, take it off to the side, and now I want to know the probability of selecting a red coin on my second draw. Okay, so first, if a green coin is drawn and put off to the side, how many red coins are still left in the bag? Well, there's no red coins have been taken out, right? So there's still 6 red coins in the bag, right? How many total coins are still in the bag? Well, 1 coin did get taken out, so there's no longer 18 coins. Now there's 1 less, so now we have 17 coins left. So the probability now of selecting a red coin is 6 over 17. Okay? All right, moving on. Complementary events. Complementary events we actually talked about a little bit in Wednesday's lesson. Okay, so the complement of an event is the set of all outcomes that are not the event. Okay, so for example, let's say you flip a coin. Complementary events would be heads and tails, right? So I could flip heads. Okay, its complement would be flipping tails. Okay, the sum of the probabilities of an event and its complement is always 1. So there's a 50% chance of flipping heads. There's also a 50% chance of flipping tails. If you add 50 and 50 together, you get 100%, which is 1, right? So for example, the event of rolling a 6 on a number cube, okay, let's say my goal is to roll a 6 on a dice. The complement of rolling a 6 would be any other outcome, which would be 1, 2, 3, 4, or 5. Okay. All right, so let's look at this example 1. There are 2 red kings in a standard deck of 52 cards. So I've got a deck of cards. 2 of those cards are red kings, right? You got 2 red kings and 2 black kings. I want to know what the probability is of not getting a red king if you select 1 card at random from a deck. Okay, well, first of all, we know that the probability of event plus its complement is equal to 1. So we also should know then the probability of a red king plus the probability of not a red king. So like not a red king is the complement of getting a red king, right? So first, what's the probability of getting a red king? Well, there's a total of 52 cards in a deck of cards. 2 of those cards are red kings, okay? Which means that every other outcome is the complement. The probability of not getting a red king is everything else. So there's still 52 cards in the deck, right? How many of those cards are not a red king? Well, it's everything except these 2 right here, right? So there's 50 are not red kings. Okay? And that's equal to 1. So this right here is the probability of not getting a red king. Now this can be reduced, right? If we divide 50 and 52 both by 2, we get 25 out of 26. This is the probability of not getting a red king. Okay, it's basically everything else in the deck. Okay. All right, here I want you to try this on your own. See if you can figure out this probability. There are 4 suits in a standard deck of 52 cards. There's spades, hearts, clubs, and diamonds. There's an equal number of each suit, right? There's 12 of each. Or is it 13? Maybe it's 13. Yeah, it's 13. Okay, 13 cards of each suit. Spades and clubs are black, while hearts and diamonds are red. What is the probability of not getting a club if you select 1 card at random? Well, the probability of getting a club, there's 4 suits, okay? 4 total suits in a deck of cards. 1 of those is a club, right? So the probability of getting a club is 1/4, which means the probability of not getting a club is everything else, okay? Which is 3/4. Okay, that's the probability of not getting a club. Okay, the last thing we're going to talk about is mutually exclusive events. 2 events are mutually exclusive if they cannot occur in the same trial of an experiment. Okay, so like obviously you can't, if I flip a coin it can't be both heads and tails at the same time. That's impossible to get to land on both heads and tails at the same time. Okay? Unless for some reason you happen to have some weird foreign coin that has both a head and a tail on the same side of a coin. But I don't know. I've never even heard of a coin like that, and I don't even know why I said it. Okay? So it's not possible to get a head and a tail in the same flip. So heads and tails are considered mutually exclusive. Things that can't happen at the same time. So like if I draw one card from a deck, it can't be both a king and a 3, right? Those are mutually exclusive. Okay. So example 2 says you draw one card at random from a standard deck of 52 cards. Tell which of the following pairs of events are mutually exclusive. Which of these cannot happen at the same time? So first, if I draw one card, can it be both a spade and a heart? No, it cannot. So that means that these are mutually exclusive events. You cannot have both a spade and a heart at the same time. Okay, what if you draw a card? Can it be both a queen and a red queen at the same time? Well, this is kind of silly because if it's a red queen, that means it is a queen, right? So these can happen at the same time. So these are not mutually exclusive because they can happen at the same time. Okay, can you have a blackjack and a red jack at the same time? Okay, no, you cannot. So these are mutually exclusive events. Okay, can you draw a card? Can it be a red card and a diamond? Well, diamonds are all red, so yes, you can have this happen. So are these mutually exclusive? No. Remember, they're mutually exclusive if they can't both happen at the same time. Okay? All right, so that's all we have for today. Your assignment, I'm going to actually post some questions on Canvas for this assignment. So it should be linked to this video lesson. So I want you to go ahead and answer the questions that are linked to this assignment. And we will see you guys on Monday. I hope you guys have a good weekend.